This is really a preview for my workshop tomorrow. I'm going to run through it really quickly so you can get a sense of why you should come to the IPFS 201 track and get hands-on keyboard with me and write an app. Little background. Let's see, my team at DAG House, we built a bunch of developer tools, and then the NFT world came along and realized that the verifiable content identifiers that are built into IPFS are perfect for putting NFT references on blockchains, and basically blessed us as the right answer for NFTs. So we went and built a bunch of tools around that, which I'll show you at the end of my talk. And we took what we learned from those tools and built a platform, Web3.Storage, that is the easiest way to get your data on the decentralized web. So the workshop tomorrow is going to be a hands-on workshop with 2 tracks, one back-end track about how you can delegate access to your Web3.Storage accounts to your end users, etc., and then one front-end track about how easy it is to add uploads to your application. And our goal with these developer tools is to make it so you can be fresh out of code school and want to solve a problem quickly. That problem is get some uploads from your users onto your site, and we're the right solution. Not because of all the really cool reasons that we all love here at IPFS Camp, but because it's just the easiest way to get the job done. So that's what I'm going to be showing now. And again, tomorrow in the 201 track, me and Alan Shaw are going to be giving the long version of this talk where you'll actually get, run npm install and saturate the network and all that good stuff. And so I'm going to go over instead of through some of this stuff, but you're welcome to scan QR codes. This one links to GitHub. It's just what the example project looks like at the end. So maybe spend a little bit more time talking about Web3 storage and where we come from. We are focused on solving this problem that a lot of people don't really see as a problem, but the way that the centralized infrastructure providers work today puts a ton of constraints on the kinds of applications you can build. And so if you're building with a siloed or centralized identity provider, if you're building with a centralized siloed data storage provider or compute provider, there's all kinds of pain that you have to slog through every day around that goes away when your data can be anywhere. So by unlocking the data layer, we allow you to write applications that can be independent of the topologies and the vendors they're running on top of. We're going to focus mostly on the upload API in the workshop tomorrow. I'll talk about the various APIs that we've got. So W3Up is our beta upload API. If you go on our website, you're not going to see this stuff listed. This is all beta. So W3Up allows you to upload directly from the browser or the mobile device with the verified token that we give you, and your upload goes directly to the cloud without crossing through your servers. It's verifiable. You get the CID to the upload before it completes, and then your data is available on our W3 link CDN-based gateway. So when you fetch those images via HTTP, they're going to be as fast as anything that any of your competitors in Web 2 are doing, because we have a worldwide content delivery network. And then we've also got additional features that you need in a world of immutable content IDs, like W3 name, which is our change feed IPNS naming feature. But today we're going to focus on how we do the storage. And it is growing pretty quickly. You can see that growth didn't slow down, kind of even as some of the focus shifted from NFTs. And we've got a ton of users across all different industries. So as I mentioned before, the tools that we build allow you to write applications that can run on lots of different vendors. And the reason that's the case is because we use open protocols like IPFS, which everyone here is familiar with. but also like DIDs, which are a web standard for identity that allows you to work with the cryptographic signing capabilities that are built into the browser. And we are one of the early adopters of UCAN, which is pretty sweet if you ask me, in that it allows for all these cool features that basically fall out because it was built right in the first place. So if we like play the history game for a second, at the beginning of the web there were cookies. And the old style cookie would just be an ID that when you hit the server, it would go look that ID up in a database and be like, oh, that's JChris, pro account. And then that got to be tedious, so we realized that if you sign that cookie, you don't have to do a database lookup. Like, I wrote in the cookie right there, it's JChris, and he's got a pro account. The problem is, if somebody steals that cookie, now they can act just like me. And you can't fix that, because rather than it just being signed by the service, it's also signed by the user, using the key material that the DIDs manage. So if your UCAN's floating around, no one but you can use it, because you have to have the private key in order to invoke that capability. So we'll talk more about this, and in the workshop, you'll actually like walk through and build some code that gives third parties access to your upload account. I think this is bigger than just making it easy to do some uploads to IPFS, storage and retrieval service. What it unlocks, we like to call data anywhere, because when you're looking up data by CID, and we all know this, you don't go to a location to fetch it. You ask the network for it, and whoever gives it to you first, you can know it's the right one because it's verifiable. And so you can put them on the blockchain. You can cache them because they're immutable. We take advantage of that with our global CDN. And this universal addressing scheme means that when you write an application, the compute can assume that it's going to be fetching the blocks from a reasonably nearby IPFS.Storage provider. And so you don't have to write your code in a location-dependent manner. You can write it in a location-independent manner. Beyond just data, when we start talking about those UCAN invocations, and because of the way that they provide like a framework for authorization around the invocation, it makes it super easy for other third parties to stand up services that talk UCAN. And some of those services can be generic function runners. What we see the trend, like serverless when it started, it was in the cathedral. You had to take your function and run it in a handful of very well-maintained cathedrals. But this moves serverless to the bazaar, so that as an application author, you write functions, the functions have addresses, and you call them, but where that stuff lives doesn't really matter to your application. So I'll show off the W3Up, and this is the part where we're really going to go a lot faster than the material because I'm previewing for tomorrow. But it's a W3Up is a client library in JavaScript. It can upload files of any size, streaming. You've got verifiable uploads so that you know what the CID is going to be before the data leaves your machine. That's a cool feature because you can like in-queue that CID for processing even while the upload is still completing, and your process is done, and whoever's listening to that queue can wait for the upload to complete. Here's a quick start. Don't do this now unless you really, really want to, because come back tomorrow for the workshop. But what we'll do is we'll get you set up with a cryptographic identifier on your terminal that you can use to run uploads. And then later on in the workshop, we'll show you how you can link accounts together using that. This is what happens when you do an upload. So those signing tokens, the UCAN that I talked about earlier, what happens when you run the client is you create a cryptographic identifier, you register that with Web3.Storage, and now you start uploading. And we do it using a car transport mechanism. So cars are content archives. They're just a file with a whole bunch of IPFS blocks in it. And it can be any size, like a Unix FS directory or whatever you want to upload. And what we do when you have those car chunks is, and this is lightweight for you and for us, is you go to our UCAN access endpoint and get assigned upload URL to S3. So that upload URL only works for the content that you told us you wanted to upload. It's based on the hash of the content and the size of the content. And the bucket just fills up with car files. Elastic IPFS, which there's talks in the implementations track about, then indexes those car files and makes them available to the IPFS network. Oh, and the last thing we do is maybe something worth knowing about car files. It's kind of obvious, but until you bang your head against them, you don't see it necessarily. All the blocks in the car have the same priority, right? It's a flat namespace. There's not like a blessed block. That means it's up to you, the application author, like which is the entry point into that car. If you uploaded a Unix FS directory, there would just be the one entry point that is the top of that directory tree. But you could have an upload that is like, let's say you've got multiple IPLD data structures and you want to make a change to more than one of them. You could put the blocks that constitute those changes into one car file and upload it and have it be applied in an all or nothing way to your data structures. So car transactions, we think, are going to be the future of a lot of IPLD manipulations. I'll skip this one. It's just let's look at the code of somebody who's using it, and then I'll brag about this part. So I like to write, apps. I don't like to spend much time on them. I like to just create React app and then drop some components in. Don't want to think too hard about it. And so that's what we built with W3UI to make it super easy for developers to get IPFS uploads going on in their application with just a couple of lines of code. So if you go to this website, beta.ui.web3.storage, and we'll have time in tomorrow's workshop to really investigate it, you'll see that all the components have code sandboxes. You can click to see them live, so you can have the code sandbox and the one in your app and look at what you're doing with that. But what you'd see on there as you drill in is that it looks like this. You can add these components to your app. If you were the kind of application developer who just wanted to get it done and didn't want to pay bills, then you can give people this user experience where when they come to your app to upload for the first time, they create a Web3 storage account, and they upload to that account and then let your app know about the CID. And that works great because as an app developer, you don't have any bills to pay. And your users can own their data. They can have data from multiple apps all show up in their Web3 storage account, and they have more control over their data. So that is a great way to do like a photo gallery where it's really the user's data and you're just helping them work with it. But it also, let's say you had an existing app, a recipe app that already has a user model and it's all Web 2 or whatever, you just want to add recipe photo uploads. You can skip straight to the upload by coding your UI to use your Web3 storage account instead of the end users. So you have that flexibility. And then what we'll do really in the workshop tomorrow is build this app. So I'll just go ahead and show you it. We have these example apps that let you upload regular files like you saw with the choose file button on the screen a second ago. So all I did, and what we'll do tomorrow in the workshop, is modify that to take the base 64 image off the camera and upload it to Web3 storage. So if the Wi-Fi is cooperating, it'll pull through to the list of images below. And what's fun about building that is you end up getting to work with not just the uploader component, but also the uploads list component, which is kind of everything you need to do in order to build one of these galleries. So if you want to do this at home, maybe like go ahead and scan that QR code on the left, and this can get you into this content if you're not able to make it tomorrow. And here's the actual workshop content, both the tracks. So the front-end track, I just showed you what the end result looks like. The back-end track is maybe a little bit more challenging, but it's the one that allows you to give your end users access to your Web3 storage account to upload if you want to do it in a way that's transparent to the user. So thanks, y'all, for learning about Web3 storage. And before I close out, I have another kind of set of content to share, which is about one of our big users, I guess, NFT.Storage. So the way Web3 storage happened, as I mentioned, the NFT community blessed IPFS CIDs as the right way to reference NFT images from the blockchain. And that was before we had any tools to help them. But we saw that they were right and that we should make their lives easier. So we built NFT.Storage as a website you can go in and easily upload your NFT images and metadata. So we wanted to make it even easier than that. And that's why we created NFTUp, which I'm just clicking through to where you'd go to download it. But once it's downloaded, it looks like this. You launch the app and you paste your API key in, and then you're able to drag and drop files. So I use this all the time, as a developer when I'm wanting to get an image online for working on things. I'll just take this NFT drop. Here's a bunch of AI-generated flowers and some metadata about them. And I'll put this onto the drag and drop, and now if the Wi-Fi cooperates, they'll all upload. The end result, you get a link to the gateway that gets you into your files. Yeah. So thanks a ton, y'all. Go to NFT.Storage if you want to upload NFTs. Go to Web3.Storage if you want to build applications in this new paradigm, and join us in Web3. Thank you.